So let's start.
Let's start.
Anything? Oh, it's raining. Gra pada.
Słodko. Będzie zimne piwko. A może nie słaniaj, co? Hello, ludzie czekają tam.
Kasia, jesteś live na YouTubie przynajmniej.
Cześć ludzie! Licznie, co jest w twoim szczęściu? Zaczynamy?
Tak, chcę zamknąć okno. No tu coś wyziewa. Tam są pozamydlane? Czy
No tak.
Whoa. Whoa. You can see nothing. All the
Cool,
buildings.
come on!
Sorry. It's awesome. It's awesome. Okay. I'm starting the recording in 5. Go.
Dzień dobry. Witam wszystkich na kolejnym spotkaniu. Ani słowa. Fajnie, że jest nas sporo. Fajnie by było, żeby jeszcze więcej nas było w przyszłości. Tylko bardzo krótko Wam powiem o naszych planach na najbliższe miesiące, może nawet troszeczkę dłużej. Pierwsze, co jesteśmy Wam winni, to wielkie przeprosiny za PSD, który jeszcze się nie odbył. Niestety, tak jak Wam już nawet chyba ostatnio wspominaliśmy, trochę polegliśmy i organizacyjnie, i logistycznie, i przede wszystkim finansowo. Planujemy jednak kontynuować temat i w końcu go dokończyć. W listopadzie, to jest taka data, na którą w tym momencie celujemy. Na pewno będziemy potrzebowali Waszego bardzo dużego wsparcia, Waszej pomocy. Jak będziemy mieli jakieś konkrety, to na pewno się do Was zgłosimy, czy to na meetupie, czy naszymi mailami, innymi źródłami. Zobaczymy jeszcze, jak to pójdzie. Co się będzie działo nowego od dzisiaj? Po pierwsze, wchodzimy właśnie z nadawaniem na żywo. Jeżeli będą jakieś, także pozdrawiam wszystkich, którzy obserwują nas spoza tego pokoju. Wybaczcie, jeżeli będą jakieś przeszkody techniczne, jakieś problemy, no jest to nasz pierwszy raz, jeszcze trochę dużo rzeczy testujemy, więc mamy nadzieję, że później jak to się lepiej sprawdzi, będziecie mogli nas dołączać, nawet jeżeli nie będzie Was tutaj we Wrocławiu, na co serdecznie zapraszamy. Następna rzecz. Chcemy, żeby nas było cały czas więcej, nie tylko po to, żebyśmy mogli dzielić się swoją wiedzą, ale przede wszystkim, żebyście wy dzielili się swoją wiedzą. Żeby to zrobić, to postanowiliśmy w końcu Was posłuchać, ponieważ dochodziły do nas sygnały, że tematy, które poruszamy, dla niektórych są troszeczkę zbyt skomplikowane, że są zbyt zaawansowane, że brakuje trochę podstaw, dlatego chcemy wyjść Wam naprzeciw i trochę do tych podstaw wrócić. Na chwilę obecną, tak, dzisiaj będzie właśnie sesja, powiedzmy, podstawowa, potem trochę bardziej zaawansowana. Natomiast od następnego razu zobaczymy jeszcze dokładnie, jak to wyjdzie. Na pewno stworzymy ankietę. Będziemy chcieli się dowiedzieć, w jaki sposób Wy byście to chcieli w tym momencie mieć zorganizowane. Czy na przykład zaczniemy jakiś prosty temat, jak nie wiem, jakiś 10-15 minutowy, jak po prostu poradzić sobie z jakimś jednym prostym problemem, od czegoś zacząć, cokolwiek Wam przyjdzie do głowy, coś prostego, a potem przejść do jakiegoś tematu zaawansowanego. Albo jeżeli w danym terminie będzie takie zapotrzebowanie, bardzo chętnie zrobimy naraz dwie długie sesje. 1 godzina podstawowa w jednej sali, 2 godzina zaawansowana w drugiej sali w tym samym czasie. Nie ma z tym problemu. Także na pewno spytamy Was, w jaki sposób Wy byście to chcieli. No i zrobimy tak, żeby był Pan zadowolony. Co jeszcze? Wszystkie nasze spotkania chcemy nagrywać. Do tej pory co prawda one były nagrywane, ale w formie, która jest trudna, że tak powiem, do upublicznienia. Wszystkie materiały będą na szerze, udostępnimy Wam, będą zdjęcia, będą nagrania i sesji i właśnie tego spotkania skype'owego, który w tym momencie również jest nagrywane, również będzie udostępnione. I jeszcze jedna rzecz. Chcielibyśmy uderzyć też trochę do młodszych odbiorców, mam na myśli studentów, więc będziemy chcieli się na pewno wybrać na uczelnie wyższe, czy to Polibuda, czy w jakiekolwiek inne uczelnie, które zajmują się naszymi tematami. Jeżeli macie może jakieś znajomości na przykład na uczelni, albo macie pomysł, w jaki sposób to zrobić, albo Wy chcecie coś takiego zrobić, serdecznie zapraszamy. Dajcie nam tylko znać, ogarniemy temat, żeby w miarę dużo osób do nas dołączyło. Także taki skrót odnośnie naszych planów. Bardzo serdecznie zapraszam, a teraz our special guest, the one and only Jakub.
So, hi everybody, thanks for the introduction. I didn't understand a single word, so
Sorry.
I guess it was positive, I hope. Today I came here to speak about the testing framework Pester, and we will spend about 2 hours together. I will first show you the beginning, the introduction to Pester, and then we will go through some examples of common mistakes that people do when writing tests, and especially Pester tests. And so let's start with a bit about me. I need to open the presentation here. That's much better. So I'm with the Pester testing framework since 2013, since the end of 2013. I also am a Microsoft Most Valuable Professional. I'm owner of the project and probably the main maintainer at the moment, because there is not many people involved in the testing framework, unfortunately. But if you can get involved. Just find us on GitHub and send a pull request or improve the wiki and so on. It will help you to learn the framework, help you to learn about what people do with it. Like this guy, he is wrapping it in his product and doing all cool stuff. If you want to get in touch, then you can just follow me on Twitter, or you can follow the framework on Twitter, or you can just send me an email if you want, or if you have any questions. I'm also quite active on the PowerShell Slack in the testing room, so if you put a question in there, I will probably answer it as well. Also, thanks to the company that employs me, they sponsor my studying and they gave me some stuff to give away. So there's like pens and notepads and a few flash disks that are really small for some reason. They only have like 2 gigabytes, but you can put a copy of Pester on it and just have it with yourself. There are also some Pester stickers that I brought, and that were really a pain to print because they screw it up 2 times. So yeah. Finally, at least I got some. And now let's go on with the presentation. So I will try to take you from the first concepts to mocking in less than 1 hour, which I hope will be great for you for the start, because when I started with Pester, it was really difficult because there was nobody around that did it. And all the people that did it were developers. So I don't know, what do you do? Any of you is a developer? What's your job? Or are you in ops?
Ops, almost.
Okay, so the developer stuff, testing, unit testing, not very familiar with. That's great, because now you have the chance to learn it. So first, what is Pester? Pester is a testing framework that's written in PowerShell for PowerShell. Initially, it was written by Scott Motz, just as an implementation of RSpec that he brought from Ruby, and he wanted to have a testing framework because he wrote a module that was called PowerYAML. And Scott is a developer, even though now he is becoming more an ops guy, and so he just took an idea that he understood, which was unit testing, took the syntax of RSpec and brought it into PowerShell. But when I joined Pester, I had no idea what testing is. I had no idea what the syntax means. And I thought, yeah, I know PowerShell, but I didn't really know PowerShell, no. So that was the start. But since then, people picked up Pester and they started doing a lot of cool stuff with it, like environment validation, operation validation framework. How is your framework called, Matthias?
OVF. PPoSh OVF.
The one that you wrote?
Yeah.
That's OVF?
Yeah. PPoSh OVF.
Oh, PPoSh OVF, right. And then we have DBHX, what else? It's here in my notes.
Rabbis S2 checks.
Yeah, right. And so on. And also Microsoft uses Pester internally in their open source project PowerShell to test PowerShell itself. So the PowerShell part of PowerShell is tested by Pester, and the C# part of PowerShell is tested by NUnit, I think. So that's pretty cool. So how I started. So for me, I got this project at work and they told me, well, write this PowerShell script that will manage power states of computers, of laptops, so they can switch at night and we can put them in maintenance mode, but then we also save power. So they will turn off overnight and they will start up in the morning, and you can do all of that through the powercfg.exe. But the downside is that on Vista and Windows 7, the interface is quite different and it behaves very differently. So I got this this tutorial on PowerShell. I went for some what is it? A guy was teaching me PowerShell, and I was there for 2 days. And then I was like, yeah, I know PowerShell, let's do this. And so I started, and I did one week, 2 weeks, 3 weeks, and then I realized I have nothing. It just didn't work. You know, if you know a bit of PowerShell, then just the EQ operator, if you don't know how exactly it works, it's really weird. And so then I was like, okay, I need something that will help me test this. And I had no idea what unit testing is, but I heard about it and I read about it. And so I liked the idea of, you know, testing your code. So I started investigating. There were 3 frameworks at that time. One of them was Pester, and it had all the features that I read about on Wiki, so I chose that one. And I started with it, and I started to learn it. But at the start, I was thinking, okay, this is some kind of magic. Like, I'm not really sure what I'm doing. But in the end, I realized it's really, really simple. So I will try to teach you that. The testing is simple unless you make it difficult for yourself. So we could start with some theory of testing, cyclomatic complexity, stuff like that, and so on. But let's just go with this. Testing is basically, you say, if this, then that. So you give it some input, and you expect some output. So you say, here is 1 and 1, and I expect 2. And so you just code that, you put your function in, and you try if it does that, what you expect. And that's it. That's pretty much all testing. It sounds really simple, but for me, it took me probably like half a month to realize that I'm not doing anything difficult. I'm just writing down the rules of what should happen. And then it started to get really difficult to read my tests, and so I realized, okay, I need to keep it simple. So that's another rule that you should do. If it starts to be difficult, complex, then you're probably doing something wrong. So don't make complex stuff. Maybe go and ask somebody, okay, how should I do this? There's a lot of people doing Pester nowadays, so you can just leverage their knowledge, ask on PowerShell Slack testing, or ask on Gitter, ask on any forum. People will just jump on it and help you. And the last one, keep it readable. We will go through all of this in more detail in the second presentation, where I will tell you exactly what you should do, what you shouldn't do, but just keep it readable for yourself. If it's not readable, then nobody can understand what you are actually testing, and then you don't get any advantages out of your tests. So installing Pester, really easy. On Windows 10, it's built in, but there is really old version, so you should probably update anyway. So pretty much on every version of PowerShell that is since PowerShell 3, you have PowerShell Gallery available, so you can just do install module, and you specify name Pester. On Windows 10, you should specify this skip publisher check flag, so you will overwrite the version that's already shipped with Windows. That's very unfortunate, because if it wasn't in Windows, then we wouldn't have this complication. But yeah, what can we do? They are taking it out in PowerShell 6, so yeah, it will be better. And that's pretty much it, and then you can just run any of the commands that Pester has, and it will be auto-loaded, and you will have it available. We're also shipping to Chocolatey and NuGet and MyGet, and that's probably all the sources, and you can also download it on GitHub. So it's available in AppFair, in any other place where you want to automatically download Pester. Use it for your continuous integration build and so on, which should be really easy. So now the syntax. So it's just 4 words. It used to be 5, but now 2 of them are the same, so we will just focus on 4. The first one is should. So should is an assertion, and it helps you to check values. So what does that mean? You have something like this. So you have 3 hashtags, and you have a function that's called replace hashtag, and you say, I want to replace it with a star. So you call the function, and then you just call should, and you say, okay, the result should be 3 stars. So pretty much, if this, then that. This is the 3 hashtags on the start, and that is the 3 asterisks on the end. And should be is an assertion, and what you should really know, and I really cannot stress that enough about assertions, assertions are just ifs and exceptions. because every framework that you will come up to in language that has structured exception handling will use this kind of assertions. You will have some if, and then you will throw an exception, and then the framework will catch it, and it will fail the test. So we will come back to that in the next presentation, but just remember this. Assertions are just ifs and exceptions. The next keyword is it, and you use it to put your tests in it. So we leave the syntax very free, so you can pretty much put the it wherever you want. But you really need to use this because otherwise your test would fail. So it is the test itself. You give it a name, and then you give it the script block in which you put your test code. If there is an assertion in it or not, it doesn't really matter as long as there is an exception that will fail the test, your test will fail. So it's really easy, you can just put it like that, and internally it's kind of just this. So you have a function that's called it takes some name, and then you give it a script block that you will execute inside of a try-catch block. If any exception happens, usually an exception that comes from an assertion, then we will write red output, and if there is no exception or nothing happens, then we will write green output. So really simple like that. Then we have describe and context. So those are the same in Pester 4 and the newer versions, because then you can take describe, put context in it, put describe in it, put context in it, and so on, and you can do multiple layers. Because describe is only used for grouping the it blocks together, so you can get more descriptions of what should be happening where you are in the test run, and you can also do some setup in it. But for the setup itself, we also have after each and after all and before each and before all keywords, which are better to use because then the Pester framework itself controls when the code will be executed and so on. But let's not go too deep into it. This is the introduction, right? So using a describe or a context is done like this. You have describe, you give it some name, then you have a script block, and then you execute some code in it. You can already see that everything is very freeform because everything is just code, which can be great for the reasons that you can organize your tests how you want. You can put ifs around them. You can do whatever you want because everything is just code that will execute. On the other hand, what would be, for example, nice for me as a developer is if I could just run one test. Just say, I want to run this it, and I have like 40 other its inside of this describe. And this is not really possible because we cannot split the discovery of the tests from the execution. Because the code, all of the code needs to be executed because the describe executes the script block, and then inside of that we execute the it that executes the other script block. So we cannot really index through all of the files to see what test we have and just go to the one test and just execute it by itself. So it's a trade-off, but I think it's a nice trade-off because then we can do the stuff that you do. Yay. Yeah, this is pretty much how it's implemented inside. I have another whole talk that takes an hour and a bit that describes all of the stuff and how it's internally implemented. But this is the gist. So if you want to write your own testing framework, you can pretty much do it in like 20 lines of code, maybe without mocking. But it will execute, it will show you the messages, and it's a nice exercise if you want to just play with the idea and really enforce that you understand what's happening. And then we have mock, and mock is the most interesting part of the framework, both the implementation side and the usage side. So mock is used to replace a service that, or let's say a function that you would otherwise have to depend on, and that function probably depends on some infrastructure. So for example, you have get 80 user, which would give you a user from Active Directory. And so if you call that commandlet, it will connect to Active Directory, it will list the users and so on. And sometimes you just don't want to do all of that. You just want to get the object and test something about it, like we want to filter all the users that are not active for the past month. So for that, we don't need real 80. We just need a list of users where some of them are active, some of them are not active. And so we want to just take the dependency and cut it somewhere. And for that, we use mock. So we replace the implementation that's real with implementation that fits our test much better. But there's also some trade-offs, and we will get to that in the next presentation as well. So if we wanted to see how mock works, then it's pretty much like this. So we would have this remove item built-in commandlet, and then we use function shadowing to hide the remove item. So this part, I will just show it on the screen so that people on the call have it as well. So this part would be what the mock internally would kind of do. So it would shadow the remove item function with an empty implementation. So if we go here and we then call remove item, instead of picking up this real commandlet, we will pick up this function that we specified. And so also what mock internally does is that it counts how many times we called remove item, and it cleans up automatically and so on. And it's also quite complicated. But this is the idea. We use function shadowing to provide our own implementation of the function when we call it, so we can kind of cut off the infrastructure and just run our tests in vacuum.
Question here, if you don't mind.
Yeah, of course, come on.
Does the shadow implementation of on Pester allows to extend the existing functions with additional arguments, for instance, or returning additional results?
Yeah, so it's not exactly function shadowing, but that wouldn't answer your question. How it works is that there is this rules of lookup, how functions are looked up in PowerShell. So you have aliases, functions, commandlets, and so on. So we are adding an alias that will be called remove item inside of, and that points to a function that we generate. And the function that we generate from the original function. So we take all the parameter sets it has, and through the proxy command type, we generate the body and the param of the function. And then we define the function with a random name, and then this alias points to it. So the parameter stays the same. And no, we don't have anything that would enable you to extend it. But what you can do is that you just define your own empty function with the parameters that you need. And then you mock that. So you will pretty much do this first step yourself. And then if you mock it, then you will be mocking your function and not the original commandlet. And you will still get the command or the function shadowing playing the role in it. So you will call remove item that would normally call the function that you just defined with the parameters, but you created a mock for it that will generate all the code that will do the counting and all the stuff that you need. So you will never get back to the original function. Why do you ask? Did I explain it in a way that you can...
These mocking functions are the available within functions namespace.
I'm sorry?
The functions drive, PS drive.
Yeah.
Are those mocking functions available within that that drive?
They are, but they have a random name, and then so we have a function, like a real function, that's defined in the function scope that you have available through the function drive, and then we have an alias for that, because there is also a problem that you cannot manipulate functions just in the scope. So you cannot say this function is defined within this scope and then go and remove it from that scope. Yeah, it's very difficult. So we need to use aliases, because aliases die correctly when they run out of scope. They will be not available anymore, and the original function will be available anymore. But then we also need to go and delete the random function. So in the function scope, we have the function with the random name. We call it bootstrap function, and that has the same parameters as the original function. And then we point to it through the alias. And we rely on PowerShell to kill the alias when we run out of scope. And then we need to do cleanup. But if we don't do cleanup, nothing happens really, because unless you call a function with a random name and you just, guess the name correctly, then you would call the mock again. But from the normal point of view, you're calling what? Remove item. So you call normal remove item, then you mock it, you call remove item alias, then it runs out of scope, you call normal remove item again. Okay? Did that answer your question?
Yeah.
Did it?
Yeah.
I'm surprised. Now this next slide probably gets totally different message. It's no magic. No, it really is logical how it works. It's only a bit complicated, but once you understand how it works, it's really quite simple. You just define an alias, point to another function, and maybe generate some dynamic parameters and so on. Nothing really difficult. So let's try some practical examples that I come up with that should highlight some of the basic ideas and basic shapes of tests, or not actually basic shapes, all the shapes that I have ever encountered with testing. There are only 3 of them, basically. And I will try to set up some context first. You don't have to really understand it, but I just want to show you that this is coming from real life example of something that I was developing, not from something that I'm just trying to push here as a part of a presentation, so I really have some use for it. So who knows Jenkins? Anyone familiar with it? Just 2 people? 3, 4? Okay. So Jenkins is this build server tool that's probably the one and first open source build tool. I don't really like it, but I use it for a few projects. And what it does, it runs steps. So pretty much it's a server, you give it some task and you say do this, do that, do this, do that, and so on, and you use it to build your code and deploy it and so on. You look suspicious. Why? That's what Jenkins is, right? And the great thing about Jenkins is that you can run PowerShell on it. So when I automate something, I probably do some setup in PowerShell, then maybe they already have a special task where I can build and test my C# code. So I will plug that in, and then the C# code produces some DLLs, and I take them and I package them into Docker and publish that into some Docker repository, and that's exactly what I was doing. And then around all of this, there is this environment that's represented by environment variables, but it's not the env drive in PowerShell or the environment variables of Windows, because we want to be able to run multiple builds at the same time, so we want to set the environment for each of the builds. And this environment is represented by environment variables in Jenkins that have this format, so capital letters, _ID, and that's pretty much it. So they are just variables that are in the environment, kind of like if you would be accessing the $env colon and the name. And I was using this to build my build and to set all the configuration and so on. And then the second thing I was doing is that I was using this semantic versioning that was provided by a tool that's called Git version. And I wanted to have this format so I can say, or publish a package that looked like this. So I would have version 1.1.0, that was my deployment version, then I would have this one. So I can say I've built this version from this commit exactly. And then we would have those other versions that would be generated from every commit at the end of the build, so we can get back to all of the images that we had, synchronize, make sure, okay, this one we already built, we will test it, and once we have tested it, we could take it and republish it as this one, for example. So from this, you just need to understand, or just understand the format. So that's how my format looked like, and that's what we will try to do. Create a version string that looks like this, and create environment variable string that looks like this. And then, as I said, I was using this tool, and I was telling you about the get AD and the Active Directory environment that we can take dependency on, but this is also a dependency like that. So this is an external tool that has its own complex behavior, and it took me quite some time to understand the different profiles and how it will behave and so on. But it has quite a simple interface, and that's this JSON object. So normally it has a lot of properties, but we are only interested in those. And if you remember what I said about seams, so this would be one seam between our code and the outside environment that we depend on. So if we take this JSON and we generate it from somewhere, or we save it and load it, then our program shouldn't be able to tell if we're calling the real Git version or if we are just faking the input and providing it something that's set for our test to, give us some idea of if the code works or not. So this is what the Git version produces, and it's just a JSON object that we will be using. So task number 1, convert a Git hash to short hash. Is there any volunteer who wants to do this? Come on, guys. It will be really simple. So
Pretty with the command line switch pretty,
okay,
git log and 1 and pretty.
okay. Let's first see the test, and then you can show me how to do it correctly, and then I will show you how I did it. So this is what we will be doing. We have this long hash. We only need to cut it to 7 letters, which is not very conventional. Could have been 8. And we have a test for this. So where's that? Yeah, this is it. So let's just run this test. And did it run? Maybe not. See what? Let's try again. Oh, it ran. So here on the bottom, you can see that we got a test and it failed. Can you read it in the back? Should I make it a bit bigger? Probably a bit bigger. Oh, that's one way. That's what we got. So 24. No.
Check error.
Oh, it should be a number. And yeah, whatever. Let's just go with this one. If it doesn't want to work, you will have to squint if you cannot read it, or come closer and be wrong here. So we have a test that looks like this. No, don't say. And what we're doing here is that we feed off a function with a long hash, and then we call the function on the hash, and then we say should be, which is our assertion, and then we are asserting that we got the correct result. So no get.exe is involved in here, so we are just taking a string and making it shorter. So how would you do that in PowerShell? Any ideas? Any volunteers?
Arise.
Erase? Yeah.
Just
Regex.
You want to do it with regex? Now you have 2
Hash.
problems. So
hash dot length and -1. I mean it would be.
Split it into chars and then just combine the chars.
you can type it in.
I can try.
Do it. Just remember, we only want the first 7 letters.
Could you get if you could be a little bit louder? Because people are saying that when you are far away from the laptop, you're being heard better than near the laptop.
Some strange keyboard.
When you are at the laptop typing, just try to speak more loudly because I think laptop is kind of the hard. Where's the mic? Are you using the mic from the laptop or on the camera?
I think one at a top.
So you're
I would just be
one laptop is connected to my phone. So you're either using the integrated or the camera one.
In length.
Yeah, it doesn't.
That should work. I can just type that in for you if you want.
Minus.
But that would give us like everything except the 7 digits from the end.
Yeah, so.
So what I would do, I would just do 0 to 5, 6, something. Maybe we can just do 0 to 5 and just run the test and see if it fails. Okay, let's try this one.
But that will just.
It doesn't matter if it's correct or not.
Oh.
The thing is, we have the test so we can check if we went to the correct solution, and if we didn't, we can try again. That's why we write tests, just to make sure that what we are implementing works. Ooh, F5. So now we get cannot index into a null array. Okay, not what we wanted. So I know the answer, so I know that we don't need this complicated thing. We just can say 0 to 6. But let's try 0 to 5 and just, we made an error. We didn't really count in our head. Or, yeah, we said 7 instead of 6 because we didn't realize that we are indexing from 0.
Is the brackets? The bracket.
Yeah.
Yeah. And we can run it again and see what happens. And so we wanted CA146AB, but we got an array that has almost all the items, but it has one more. So now we can go 2 ways. We can either fix the problem with the array first, or we can remove the last item. So let's remove the last item first. So that should be 6. We don't really have to think because the tests are helping us out. And run it again. And so now to connect it together, what would you do?
Just the add and brackets. So put all the input into the add sign.
Add sign?
Yeah, add bracket, opening bracket, and then closing bracket.
Or just.
So that's still an array.
Yeah, or just use a type.
To string?
The other one runs.
How about join?
Join with comma? No.
We probably don't even need brackets. Yay, it works. Common effort. No, but you can see how many opinions we can have on code that's as simple as this, and this wasn't my first solution. I was also doing toString, but then you are depending on the OFS, the format separator something setting, and so on. And so if we have tests, we have something that we got, something that we want, and then it doesn't really matter how we implement it, as long as it's doing the right thing. And that's one of the beauties of the test, that you can refactor without fear of breaking everything, which was a big problem for me when I was developing my Power Manager solution, because it was really difficult to test it in real life. I had to go to the station, run it, then it might have make my computer sleep, it might have turn it off, and it took a lot of time, and then it had to pop up, and there were some waits, and so on. And then it was different on Windows 7 and on Windows Vista. And so without any tests, for me, just testing if this one version where I made one change in one file works could take like half a day, maybe more. And it was painstaking thing to do because it was really boring. And I could make a lot of mistakes. And then I started covering with tests, and so even though this test looks really stupid simple, then it will help you ensure that this piece of the jigsaw just works. And so you can make sure, okay, this string is shortening correctly. And if you have a long list of the tests, then a long list of items is tested automatically. So you just then go to the computer and just run it, and you just say, this should sleep in 10 minutes. It sleeps in 10 minutes, probably most of the other small things work as well. Okay, so that's the first task. Is the audio now okay, or should I speak even more loudly?
I don't know. I don't know.
Cool. So if we think about the shape of the thing that we just did, we have a function that's in the middle, and we gave it an input and tested the output. This is the easiest test that you can do. And if your function has no side effects, so it doesn't read anything from anywhere or it doesn't save anything from anywhere, it's really easy to test because then it's deterministic. The input and the output are mapping together. And if you run the function a million times, it should always map the same values to the same output. So for you to test, it's just a matter of taking the inputs and testing the correct outputs. And so if you start structuring your functions in this pure way, then you will have easy time of testing your logic. And then on the sides you can put the side effects like read from file, update the file, all of that you can do in memory and then save the file. So this one thing in the middle of the logic would be your pure function that you have easy time testing because you just provide strings and you output strings. And then on the sides you put the real reading from the file and saving to the file. So this is probably the most used shape I use when testing because I try to steer my logic towards this shape. The second task is still using the same shape, but we will use it to showcase a test cases feature of Pester. Test cases are a feature that you can use on it. So you have the same test body with the same logic, and then you put different examples over it, which is really useful when you have a function that has some edge cases. So you start with the normal case, like here's a hash that has, enough letters, should be shortened to 7, and then you start coming up with different edge cases, like what happens if I provide null? What happens if I provide hash that only has 5 letters? Should I pad it with zeros or should I just leave it be? And so on. So you can use the same test body and just say this is the input that I want, this is the output that I want, and this is the edge case, and this is what should happen in case of the edge case. So this task, we will take a string like this and we will convert it into this Jenkins style environment variable format. So, volunteers? No? That's no fun. Should I choose somebody?
First string split after 5 letters, uppercase, join those two arrays with the underscore.
5 letters.
So it
So you
was a
want-
string
you want to write it
operation,
in.
not number operations.
I will show you the test and then we can implement it together. So this is one, this is the other one. So that's the same file. So this is the test. We have the test cases, and the test cases are used like this. We have this description of the test, and inside of it, we can use this token value, and we denote the tokens by using the pointy brackets. And then inside of it, we write some text. And then this text will be used in here as a part of the hash table, so we can provide the values. And then it will be also used in here in the parameter for the script block. So we will take this value from this first test case, expand it in here, so it's in the description, and then we can easily see it in the output on the build server. And then we will provide it inside of the script log through this value parameter, and then we will use it in here. So for each of those test cases, we will generate one test, and we will run it. So in this case, if we run the first test, the value will become NuGet version, and the expected will become NuGet underscore version in capitals. Make sense? Can you see how you would use it to add a null value and then check that you got something back? Or something that doesn't have any capital letters, and then you should get just one word with all capital letters, or something like that, no underscores. Or maybe something that already has underscores in it. So still the conversion should work. So, any ideas how to implement this?
Is there any way we can distinguish letter purely PowerShell to string, or should we use the ASCII codes?
I would do it in a way that's the easiest to implement, the fastest, the simplest. You can use regex.
No.
Why not? That's the easiest way.
So there are two kind of correct values. The one with only 3 letters and underscore, and the second one, and this new get version without underscore.
It is with underscore, isn't it? Come on. So here we have underscore because we have capital letter, then second capital letter, and then we want to add underscore in the middle, so we separate the words and then we make it all uppercase. And then in this case we have all capital letters, so I just decided every capital letter will be followed by the rest of the word, and then we will have underscore to separate it from the next capital.
So you're basically running one operation. Detect the capital letter, and for each time if it occurs, add underscore.
Yes.
Unless it's last one.
First one, right?
No,
First.
unless you don't add the underscore after the last capital letter.
Okay, what if we add it before every capital letter? Then we only have one that's on the start. How about that?
No, because it will add before the first one, so it also won't.
So let's pick the first one, yeah?
Okay. And,
Last or first, doesn't matter.
and then we remove it, right? what was your idea? So volunteers? Anyone wants to implement it? Anyone has an idea? We just implement it, run the test. If it works, we do hooray, awesome, celebration. And if it doesn't, then we just fix it. No problem. No wrong answers. You want to implement it? No?
How can I
Okay,
find?
there's the select string case sensitive.
Select string, case sensitive.
Yeah, select string dash case sensitive.
Okay. That's a new one. So what do we do? Like name.
It's kind of regex.
Can we just do straight up regex?
Yeah, so the select string dash case sensitive, and then select the uppercase AZ. So the
Okay, I will just. Did I run the test already? I didn't. I will just run the test first to see it fail, because we always should do that first. Yeah. So it fails. It says expected new conversion, but got null. Then we can just try to fake it, and we just return name to give it some value to work with. Run it again, and we say, oh, okay, we wanted A underscore B underscore C, but we got A, B, C, because that's what we provided. So the solution was, you were saying?
yeah, then the fifth line we already had. So case sensitive, the quotes, double quotes.
Yeah.
Square bracket A dash C, and that should give you all this uppercase letters from the string right now.
Okay. What do I do with that?
Space dash all matches.
Yeah.
Can you run it and see what's going on?
I can.
Just one line of it.
So now we got the same thing back.
Yeah. So then the whole thing in the brackets. Then matches value. Yeah, sorry.
Right.
Yeah, dot matches.
Oh yeah. Dot matches dot
Value.
value.
So we should get only.
Okay, but that's not that's what I want. I
Yeah,
want the
the
whole.
first step, we've got the uppercase letters from the string.
Okay.
So now we can get
Split.
after each match, we can get the capital letter, then the underscore, and then the rest of the string, and then again the operation, so the recursion for that.
You can. I think you can split.
Or try to join by underscore.
Join this one by underscore.
Yeah.
But then I only will get n underscore b.
Yeah.
Come on. I'm at the end now, so yeah. Yes. And join by underscore. Yeah, and underscore b. So maybe I can show you how I did it, because I think we got the point. Like we run the test again and we see what should happen. So I also
Could
use
you
regex.
assign this?
Yeah, you can write it in.
Whoa.
Let me just type it for you if you want. Yeah.
No, it's no normal.
It is. It's an English keyboard.
Equal. Yeah. So no.
Guys, those sounds are really great.
Split A.
Split.
No, the
Dollar.
Yeah, right.
Yeah. And in brackets.
Did I
Dot.
move the camera out of focus?
What?
Did I move the camera because I touched the cable and
Yeah,
it
it's good.
seemed turned?
It's good. It's good.
So yeah.
Brackets.
Unviewable.
No.
Like parentheses.
Too many engineers in the room.
Join.
It would be easier to get a student to do that, right? Manually. Just let it go.
Okay. Whoa. I have no idea what's gonna happen.
That's important.
Please don't blow up.
Whoa.
Great solution.
V to int.
Input string is not in correct format. Okay. So let me show you how I did it.
Delete.
So pretty much what you said. Just replay, or what we said.
The same.
Let's replace the letter that we have, if it's capital, with itself and underscore, and then just trim the first underscore. And then you are there. Which we can do by just saying name, C replace, because we need case sensitivity, A to Z, but with capitals. Oh, come on. Thank to Z. And we replace it with itself. And now we should get underscore before every capital letter,
Why 0?
because that's the first capture group, and the first capture group is always everything. Haven't you been to the regex presentation?
Now we have 2 problems.
No, you can use this in multiple places, like almost every editor supports it. So if you want to replace something, like you have some text and you want to wrap it in something, then you just write regex, you put parentheses around it, and then it will be the first capture group. If you don't put any parentheses, then it will be the 0 capture group. And the more you add, the more capture groups you will have. So now we don't have any capture groups, so we will get the 0. That's all the matches that we have in the regex. So now we should be getting almost the correct result with the underscore on the top. And yeah, that's what we wanted, like ABC underscore. And now what we need to do is we just remove the first underscore, which we can do by trimming. So we can do either trim or trim start, which is more explicit. Let me just say remove the underscore.
But you're mixing .NET methods with PowerShell.
Still, it works.
Until you find that the .NET methods has really a lot of small details which could be reason for mistakes. Exactly with the trim or string methods.
You are right, but PowerShell is also .NET, and that's why we write tests. So we can say this is the examples that we want to work, and they should be working like this. And then we don't really care if the code is working wrongly, because if it is, then we found an edge case that we need to solve somehow. And it might be an edge case of the method that we're using, edge case of trim, and we can replace it with a different method. But we can take this edge case, put it in our test cases, and once for all just solve this problem. If, you know, trimming an underscore would be a problem because the trim start would implement some wildcard pattern that's not standard and would be trying to do something that we don't want, then we can put it inside of the test cases. And so if somebody comes back and says, "Whoa, what is this stupid guy doing?" we can just trim start on it and replaces it and broke the functionality, then you have it in your tests.
Yeah, I just thinking about the situation when somebody actually reads the function code and interpret the dot methods as they will work in PowerShell.
Okay, can we just do it this way then? So we just replace the underscore on the start. That should work as well, I hope.
Yeah, let's see.
Let's see. Oh, just keep pressing Ctrl R.
Yeah.
Works as well. It pretty much does the same thing. Trim
Yeah,
start,
but
with
now-
regex and it's slower.
But now nobody who reads the code of this function needs to go to the .NET documentation and read the .NET C# code. He will use the PowerShell knowledge, not
Okay.
the .NET knowledge.
Yeah, I think that's a fair point. That was just my implementation because well, I'm a .NET developer. So I use the tools that I know. But yeah, this is also nice. Then you could probably argue like, who knows what C replace is? Not many people, but many people are aware that the replace is, you know, case insensitive by default.
I think the PowerShell admins know this, but the .NET developers are surprised by this.
Yeah, well, the same, like, a lot of people is surprised by how EQ works and so on. But yeah, fair point. I think if we want to stay within the realm of PowerShell, that's why we also have tests for, so we can have multiple implementations, and as long as they work the same, then we can use them. And then we can start adding stuff like, this is too slow, or this is not performing as we want, but in PowerShell we usually don't go with this, like, this is too slow, usually it's fast enough. Okay, so that was the same shape of the function. I just wanted to show you the test cases. How are we doing on the time, by the way?
It's up to you.
Okay.
All the time.
Right.
The
And
business
so,
should be in like 15 minutes.
yeah, I think we will be able to finish that maybe. So the test cases are really useful because you can reuse the same body and you don't have to copy code around and so on. And I use them pretty much for every test because usually I go back and add some edge cases and I don't want to rewrite it and I don't want to need to change the code afterwards because I know that probably there will be another test case. And if it won't be me who writes it, it might be somebody else who comes to the code base and tries to add it, so then it's easier for him as well. Another task, that one is really easy. We should be able to do this as well. We need to compose the version string, and we saw that we have this Git version output and we have some date, and composing the string out of it is not very difficult. What's difficult in here is that the Git version is an external dependency that needs a Git repository to be present in some state and so on, and just to be able to get the JSON object. So for us it's better to fake out the Git version because what we will be doing is something really simple, and that's connecting strings together. And then the same problem is with date. Date depends on our environment, on what the time is and so on. So we don't want to rely on that in the tests because then we couldn't really write the tests. So code. We have this get version. We'll put the tests in here. And this is the function implementation that we will be writing. So here we can see that I already did all the setup that we need. So let's just run it. It will fail. If it will run. Okay, so it says we wanted this version string, but we got null, which is not very surprising because the function on the other side doesn't do anything. And so I did all the setup for you. So we have this external dependency that's called git version, and we want to cut our code from it because we are only interested in the output. What we don't want to do is that we need to set up a new Git repository, do a commit inside of it, do a tag over it, just so we can get this information. And then the second dependency that's external is getDate, and getDate in PowerShell is represented by the getDate commandlet. So we can also fake that, and we can create a new date object and output that instead. So we make it work the same way the normal getDate would work, but we no longer depend on the environment. So now we can run those tests pretty much on any machine, and we will still be getting the same data from Git version. So we stabilize the external dependencies. So who wants to implement this? That's really easy. You just join strings. Now what?
This is 0 dash 1 dot 3. I mean, first build a concatenate string from the format thing, and then just feed it with the objects.
Oh, this way. Okay. With the format.
Yeah.
0
dash 1 dot 3 plus 4.
Just right. 2. Come on.
Plus
3.
1, 2, 3. Minus it will be version dot major minor patch. I mean version dot. You have to go inside the object. So version dot major minor patch.
Major
version pre-release tag. Then
Right.
it's date, so
I will just put it in like explicit array so we can see it.
date.
Date. No. Date first, right?
Yeah, date. And then the short hash.
No problem, just like it. So we run it and it works. Let's just switch up the things so we can see it fail. I can just add it and it would be wrong. Okay, cool. So in this test, building the string is really simple, but we need to think about where the edges of our code are and what we are depending on, and also what we are replacing the dependencies with if we decide to replace them. So in this case, what I did is that I just took the Git version, I created a new Git repository, put it in the state that I want for the test, run Git version, exported it through the JSON object, just read it from the console, put it in here, and said, okay, I don't need the rest of the properties, but I might have saved them in the test script as well. But then you would have to wonder, like, what's the things that we use actually, and so on. So I just took the things that I need, put it in the JSON, made sure that it's the same as what Git version gives me, and that way I didn't introduce any error in like, this is how Git version works, this is what I think it works, because I'm only returning the JSON. And I did the same thing with the get date. So I run the get date, see, okay, it returns date time, so I will produce new date time. One thing that you shouldn't do in the mock is that you call the original commandlet, because then it gets into loop and it gets stuck. But what you can do is that you call get command, you look up the commandlet, and you have to specify that you want the command type commandlet. Then you will get the original one, not the alias that we are creating. And then you can invoke it through the ampersand operator to make it run. So with getDate, it's really simple. We have access to the .NET object, so we can just create it ourselves through new object. But if we had something different, that the object would be more complex to create, we can call the original command and use it. Or maybe you can do it with write host or something like that. What? There we go. So as I said, we stabilize the dependency, and that's really important thing to do with your tests, to make sure that you can write tests that will test something that's very complex without setting it up. In the end, you should also write tests that will set up the real environment, but there you will probably have only a few tests. You have this nice pyramid of tests where you have the integration tests on the top, and you have a few of them, and then you have a lot of unit tests, and that's what we just did. We wrote a unit test, because we isolated it from the other dependencies, and we only provided the data that we wanted to provide. So if we think about the shape, then it looks kind of like this. We have some mock that is providing some data to the function, and we process it inside of the function, and then we have some output that we are testing. So we are controlling, every time we're controlling both sides, either through mock and then the output, or input then the output, or input then mock. We will get to that in a second. Okay, makes sense?
Yeah.
Good. So the last task that I had was to actually build the Docker image from my resources, and we won't be doing that in here, but I wanted to do it through PowerShell, and when you are calling external tools through PowerShell, it's usually quite difficult. So I said, okay, I will just write a function that will wrap the Docker commandlet or the Docker command, the external command, and I will just provide the parameters, and I will be able to call it in a normal PowerShell-like way. Plus, then I can mock it easily. So that was like a new seam in my application. And the seam is wrapping the external function with a function that is in PowerShell, so then I can take a mock and like cut it in half and replace this implementation with something that will be working for the test. And here we should again think about what we are providing back from the mock, or what we are doing, because with every mock we are reducing how real life the function is. So we can introduce some errors and we can say this works this way, but it doesn't really. So what you should do every time is that you run the real command, you capture the output, or you try to run the real command and you capture how you call it, and so on. Okay, demo. So this is the function, this is the test. So in the function, I wrote this helper function that only wraps the Docker commandlet, or the Docker command that's called Docker, and then you tell it build, which is like a parameter for it that says build an image, and then you give it a tag, and then you give it a path. Maybe you can already spot that there is a mistake in it. There should be $path, but there is a dot instead. And that's something that's a risk of mocking out the environment, that you don't provide the parameters, and that's why you should also write integration tests, because otherwise you are not sure that it really works. But you can use the mocks to test the happy path, to test the sad path, and nulls and edge cases, but then you should at least once run it in the real case scenario so you can see it still works. And then I have this another function that's called new Docker image, and there I want to get the version from the other function that we just wrote, and I want to put it together into the tag, and then I want to call my wrapper function that's called build Docker image. And here I will believe that I passed the parameters correctly, even though I didn't. And I will just test, if I run this function, do I call this other function with the correct parameters? Which you normally do pretty much against functions that come built in with PowerShell, because there you know that thousands or millions of people are using them. So your only concern is not does this work correctly, but am I calling it correctly? And that's where you can use it. So you just say, if I call remove item with this path, then it should remove the item, or it will throw an exception, maybe. But if you call it with the correct path, it will probably remove the item, most likely, because it's tested, Microsoft tested it, everybody uses it, so it's kind of proven to work by usage. So let's run the test. And we hit a breakpoint, so let's remove the breakpoint. And so here we are creating a mock, and we are making sure that we called the mock with the correct parameters, which we didn't. That's why it fails. It says we expected it to be called at least once with those parameters, but it was called 0 times. So if we fix it and we call it correctly, then this error will go away, and we will make sure that our application is connected together correctly. So here we don't need to do anything special, we just call the function build image. Tag with and that should fix it. Let's hope. Hey. So the only thing that we're making sure here is that we are calling this wrapper function correctly. So the function build Docker image, and in there we are believing that we are doing the stuff correctly, even though now we don't. So if we fix this error, ideally we would get a failed test, but we don't, because this code inside of the function is behind the edge of what we are testing. So without integration test, we can have like two doors that open into each other and so on. We don't want to do that. But still, it's a very useful tool. Okay. Any questions? No? So this is the shape of what we just did. We have some input, we have a function, and then we have some mock. And the mock we verify by calling the assert mock called assertion. And we say it should have been called with those parameters at least once. You can specify how many times it should have been called. You can specify different parameter filters and so on. But this is introduction, so this is the basic stuff that you need usually, and pretty much what I need usually as well. Now the task number 5 is just a variation of what we just did. And maybe you won't need this, but I find it quite useful to learn about external tools and make sure that they still work the same way. So you can find this called discovery test. Pretty much you do something that you don't know and you write tests for it because it's quite complex. And through that you just put down the knowledge that you already have. So when I was discovering how Git version works, I created a test and where is it? This one. And so I just wrote a test and continued writing it to make sure it works how I expect. So first I went to test drive, then I did git init because I knew I need a new Git repository. Then I added a file, committed the item, and then I went here and I run git version. And I look at the object and try to make sense out of it. And I realized, okay, the version, if there is no tag, is 0.10, so that's something that I want. And so I wrote this test, just converted the output from JSON, took the major minor patch property from it, and said, okay, this should be 0.10. And then I did the next step. So I added a tag. And then I said, okay, if this tag is in here, then the version should be 7.10. And I ran the Git version and I made sure it works like that. And then I went to the settings of Git version and changed them, and this version changed and it failed and so on. But I already had this test in place, so I could see that the behavior of the Git version changed. And so it's not very difficult, but if you have some library that you don't know and you want to find out how it works, then sometimes you start at the beginning, you maybe write notes, maybe you don't, then you figure out how it worked, then you get back to it, then you get confused and so on. If you just write tests for it and you make sure it works like this, then you have some notes, you have them in the code, and you can take a new version and run it against that and make sure that it still works the same way. Which is great for APIs, great for external tools, and so on, because you set the invariant that says this is how it should behave, and if it starts behaving differently, then it's not my code that's broken, then it's the change of the behavior inside of the tool. And without tests like this, it's very difficult to detect this kind of behavior. You have to go to release notes, you have to guess, then maybe the previous version of the API is not available, something is broken, and so on. So I find this quite useful. Same idea. So before we stabilized external dependency by mocking it, and we stabilized it because we wanted to test it. Now we stabilized external dependency in the sense that if the external dependency changes, then we will know about it because our tests will start failing. So the scheme would be like this. We have in, we have some program, and then we have the output just to make it complete. So in a summary, there are only few shapes of tests that you will encounter. This is really all of them that I could have found. And so if you start to recognize the shapes, you will know how to test your functions. You can apply the same things over and over, and you will realize there is no magic. It's just 4 keywords, some shoots, some assert mock calls, and then it's just everything all over again. So if you use mocks, use them cautiously because you can, fake out too much of your environment. And most of all, experiment, have fun. So yeah, that's it. Questions?
Is that approach dependable on the version of PowerShell that one is using?
Which approach?
The approach of testing external dependencies and making sure that those objects or our code is running properly with regards to external tools returning values that we are actually not expecting.
I think it depends on the tool itself. Should I repeat the question?
Yes, please.
Okay, so the question was if the stabilizing of the external dependencies is dependent on the version of PowerShell. And I think it depends on the external tool because most of the tools will communicate with you via text or via JSON objects, and those don't really change depending on the PowerShell version. But if you would be stabilizing some like a add-in, like a module, something that you install directly into PowerShell and it comes from external source, like the PowerShell gallery, then those might be different based on the version of PowerShell. We in Pester also have different behavior based on version of PowerShell. So it might or might not be.
That's the key question because if you have some complex modules some complex solutions that requires multiple modules with exactly with exact version, if you want to have a up and running and most up-to-date code, you probably should update the modules from the gallery or other source, external source, but you cannot be sure that updating one of the modules or the DLL won't break entire solution.
Yeah, I understand that's always the problem. I'm also not saying you should only rely on this, but it might help you to detect something that happens. It might help you discover how this one version of the module works, and then if you decide to update it, you can start by updating it locally, running it against your test, and see if it still works. And if it still works, then you can update it everywhere. Or maybe you can rely on the release notes. But yeah, dependencies and versions, that's always a problem. And this can be just a tool for you. So I use it so I can discover how to do it. I don't have to, type it in PowerShell and think about what I already did. And then when I have the command that already works, I just keep it in the test framework or in the test suite. So I just don't delete it, and I have it for the future. And then when something breaks or I need to update, I update and see if it breaks. But it doesn't detect everything. Then I would have to, call every API, make sure that every small feature works, and then it would be really rigid, and you would have really a lot of problems updating, and it would be slowing you down, which is also something that you need to think about when testing. Like, do the tests, when they break, do they detect something that I wouldn't otherwise get, or are they just slowing me down from programming or inventing new features into my code? Are they helping me as well, or are they just slowing me down? And maybe if they are just slowing you down, then you might be doing it wrong, or maybe you just don't focus on the same thing. For example, together we talked on PSConf.eu, and Mateusz told me, like, I don't write unit tests. So yeah, because he is testing everything through the bigger test, because they give him much more value than writing millions of unit tests, because he just don't need it. So yeah, right? So if you don't get the value back from it, then don't do it. But yeah, this is just a small tool that you can use to stabilize your versions. Other questions? No? There's the pizza.
Where can we find some typical examples of tests written in Pester?
From the second session.
Maybe. Yeah, that's one of the problems. There is only few like examples that are complex enough so you can easily understand them. and they are not as simple as like saying here's 1 and 2, and if you add them together, then you get 3. So if you go to almost any repo at the moment and they have Pester tests, then you can look there. You can look at the tests that they have on Wester, which is like Pester for Hyper-V. I think those are pretty great.
For VMware. Just
Yeah, right, for VMware. And I have a lot of tests on my assert module, but those are mainly focused on how to test assertions. Then the PowerShell itself has a lot of tests if you want to see how you would write them in like enterprise environment and so on.
But what I'm looking for is some generic tests that can be used for testing like almost all functions and modules. Just basic stuff like it takes pipeline input, it takes argument input, it takes multiple objects, and it has command-based help. Generic stuff that I can plug any function I write.
Okay, so the general tests for help, I think June Blender wrote them, and you are writing something for stabilizing the API, right? Was that you? No? It's someone else. Oh, I know. Brian Bunky is writing it. So it's like a set of tests that will make sure that your public API of a module stays the same. So it detects, does this take pipeline input, and if it changes in the next version, it will be a breaking change. So it will highlight that. But it really depends from case to case. So for the command-based help, you can take the module from June, and the other one is called Oops, I think.
Oops.
Okay. Okay. Thank you.
So how many tests you wrote to this day for your internal modules?
I have no idea. I don't develop internal modules anymore.
Or
But for the power thingy that I had, there was like 3,000.
3,000. Okay. So how long it will take for you to write it?
As long as the project is being developed. So you go and for example, when I was writing the assert module, I took it and I wrote the first like a prototype over 1 or 2 evenings, and it had like 50, maybe 30% of the functionality that I wanted, and then I wanted to do it properly, so I started doing it like TDD way, writing the tests, and then it took me much more time. But
Yeah. So that's the question. So
okay, but then after the bot, I can just take the project, download it on my computer, and not touch it 3 months, and then run it again, add a new feature, and I know that I didn't break it. So it's totally, that's why I did it. I wanted to invest the time so I can evolve it over time and use it in the future, not just put it together because it has some quite complex behavior that I don't want to test by hand. And so now I have more tests than Pester has. But it helps me a lot to evolve the functionality and make sure that everything still works. So yeah, it takes more time, but it takes the time that you would otherwise spend debugging the issues or making sure that the stuff still works.
yeah, I just wonder how complex the project must be in order to for all this time spending writing tests
To pay off?
to pay off.
I don't know. The assertions are not very complex. We just want it to work the same way all the time, and if something changes, then someone should know. So if you take a module, you make it public, and before you publish it, you need to make sure it works some way. And then if you want to evolve it and you publish a new version, you should know it still works pretty much the same way, and there's maybe a new switch that doesn't affect anything, but the previous functionality is all there. So without tests, you just need a long list of things to do, and you need to go through each item, make sure it works, or you just spend the time on writing the tests. And it's not adding that much work, because what you would be spending debugging maybe, that you spend writing tests.
So what would be a typical percentage between real development and the actual writing unit testing?
Okay.
What's the balance?
I think we can break it right now. Move to the just breakout session. I mean, just ask questions without the video recording. The pizza should be in here in a moment. After that, we're gonna switch over to your second session. So.
Okay. Yeah, just to answer the question quickly, writing tests and real development, they are not different things. They are the same thing. Like, when you're developing something, then you write the tests and you write the code. And if you separate it, then you get something that will be legacy code in the future, and you will have to figure it out again and again. So for me, it's kind of the same thing. So yeah, it's like if you ask how much time do you spend debugging and doing development, or testing it and doing development, or deploying it, doing development, they're just part of the same thing. It's just still the same investment.
Okay.
No.
So
You don't see where you can miss.
Just a quick word for the guys in the Skype meeting. We will stop recording for a moment, for like 15-20 minutes. When the second session of Jacob will start, we will start recording as well. So stay with us, don't disconnect. We won't break the connection with the Skype. Back to you.
It's pizza time now, right?
Yeah, it should be.